Welcome to qnawire.
Hi, so over here we're told that 15 grams of an unknown non-ionic substance, that means that the Bank factor should be equal to 1, is dissolved in 250 milliliters of ethanol with the following density. The resulting solution boils at 82.1 degrees Celsius. What is the molecular weight of this unknown substance? So, first of all, to know the change of the boiling point, this would be equal to the final value minus the initial value. So, the result that we're going to get over here would be equal to 3.8 degrees Celsius. Now, recall that the change of boiling point is going to be equal to the Van Hoff factor times the molality of the solution times the boiling point. Now, let's replace the molality of the solution by amount of mole of the solute times Kb divided by kilograms of the solvent. And in addition to that, remember that the amount of mole is going to be equal to the mass divided by the molecular weight of the compound. So this equation now becomes I times mass of the solute, not molality, times Kb divided by kilograms of solvent times the molecular weight. Thus, the molecular weight would be equal to the Van Hoff factor times the mass of the solute times Kb divided by the amount of kilograms of the solvent times the change of the boiling point. Let's replace the values. Remember that the Van Hoff factor is going to be equal to 1. The mass of the solute is going to be equal to 15 grams. So 15 grams over here. Kb is going to be the value provided of 1.23 degrees Celsius. And instead of employing molality as an unit, we're going to use, in this case, it would be molality to the minus 1. So corresponds to kilograms of solvent divided by mole of solute, or divided by mole directly. Next up, we're going to have over here kilograms of solvent employed. We're going to have 250 milliliters, and we need to convert them into kilograms. So 250 milliliters of ethanol are going to have a weight of 0.789 grams per each milliliter. And finally, 1000 grams corresponds to 1 kilogram. So the kilograms of solvent would be equal to 0.19725 kilograms. 0.19725 kilograms of solvent, and multiply this by the value for the change of the boiling point by 3.8 degrees Celsius. Notice that the final units are going to be grams per mole, since degrees Celsius and degrees Celsius cancel out, and kilograms of solvent cancel out with kilograms of solvent, giving us that the molecular weight for this compound is going to be equal to 24.615 grams per mole. You can round this up to 3 significant digits, since all of the quantities given by the problem are up to that level of accuracy, which would be 24.6 grams per mole. And with that, it would be all. Thank you very much, and have a good one.